Assalamu alaikum wa rahmatullahi wa barakatuh. Bismillah ar-Rahman ar-Rahim. Today, inshallah, I will try to solve some examples regarding the strain gauges. So we will start with the example 5.5 from the textbook. Okay, so what is given in this example? The gauge factor, which is 2.03, the nominal resistance of the strain gauge and the resistances that used in the Waterstone bridge is equal to 350 ohms. If the strain delta L over L is equal to 1450 micrometer per meter is applied to this strain gauge. Find the offset voltage if Vs, this is the excitation voltage, Vs is equal to 10 volts. Okay, we need delta V, which is the output of the Waterstone bridge. We have the Waterstone bridge here. Okay, this is 350 ohms, this is 350 ohm, and this is 350 ohms, and this strain gauge here is 350 ohms initially without any strain, and the excitation voltage here is 10 volts. Okay, we need to find the voltage here, delta V, between this point, which is point A here, and this point, which is point B. We know that this delta V is equal the voltage at A minus the voltage at B. This is voltage difference between two points. And we know that VA, using voltage divider rule, we can say VA is equal to VS times 350 ohm divided by 2, because the two resistors here are equal, so this is 350 ohm plus 350 ohms. This is from voltage divider rule. Okay, so we note that this is equal, actually this is equal to Vs over 2, which is 10 volts divided by 2, this is equal to 5 volts. And it is constant. Usually this is constant, not changing. If we increase the strain, this will not be changed. It will be constant. But VB initially the same, Vs times 350 without strain divided by 350 plus 350, and this is equal to 5 volt also. This is initially. Okay, this is initially VB, the same as VA. So delta V initially is equal to 5 volt minus 5 volt, and this is equal to 0. Now if we apply strain on this gauge, VB will increase, but VA will decrease. Okay, so in this case we have, suppose that we apply a strain gauge or a strain of 1450 micrometer per meter. Okay, this one, if we apply this strain, then we have we need to find we know the gauge factor also. We can find the change in resistance, because the gauge factor is equal to delta R over strain. So in this case, delta R is equal to the gauge factor times the strain times R, and this is equal to 2.03 times the strain, which is 1450 250 micrometer. Micrometer, we have to multiply by 10 to the power minus 6 times the resistance, which is 350 ohms. This, if you calculate this, it will be 1.03 ohms. This is the change in resistance. This is delta R. Now VB, after applying this strain, VB is equal to VS, which is 10 volt, times 350 ohm plus delta R, which is 1.03. This is the new R. This is R plus delta R. This is the new R after applying the strain, divided by, again, this resistance here, 350 ohm plus 1.03 ohm. This is the new R, plus the resistance in the other branch, in the Waterston bridge, which is 350 ohm. If we calculate this, okay, it will be around 5, because we here we have the resistance is increasing, so we expect that the voltage VB will increasing, starting from 5 volt initially without strain, then this will become 5 volt, 0.007 volt. Now delta V, which is equal to VA minus VB, is equal to, this is fixed at 5 volt minus 5.007, then this will be negative 0.007 volt, which means that this is equal to 7 millivolt, because here we have 0.007, so it is multiplying this by 1000 to convert it to millivolt. So the result will be here 7 millivolt. Okay, so again delta V is equal to VA minus VB, and this is equal to 5 minus 5.007. This will be equal to 7 millivolts. We will stop at this time. We will continue with other example next video, inshallah. Thank you very much.